Today we are resuming lesson 6.1, trig ratios for any angle in standard position. Our goals for the remaining part of this lesson, which will be the next two lessons today and the next two lessons, we probably got altogether 3 more lessons to complete this section. We'll be determining the 6 trig ratios for any angle. So today we'll be looking at how we determine it, and also the trig ratios given the coordinates of a point in a terminal arm. And the subsequent lesson, we will look at determining all trig ratios for angle measure given one trig ratio. Just to review some key terms: coterminals, standard position, terminal arm, and reference angle. We'll be using mostly reference angle and terminal arm today. But to get into the first part, finding the trig ratios, I want to look back at what we call the unit circle. Some of this you may have to recap from grade 11. Now, any circle that has its origin at the center, what you do, any circle, the equation of a circle so any equation of a circle, so it's a background here, equation of a circle. A circle with its center, 0, 0, has this form, right? It's x squared plus r squared, sorry, x squared plus y squared equals r squared. R is the radius, and x and y. Now, if it was different from the center, it would be, but the general equation of a circle is x minus 8 squared plus y minus k squared equals r squared. But because the center is h and k is 0, this is your center, or you just refer to the center of the circle. If this is 0, 0, then it becomes x squared plus y squared equals r squared. Now that's the background, so you need to remember that. So now let's look at what we call a circle, what we call a unit circle. It's called a unit circle. We make the radius 1. In this case, we make the radius is 1. And so, for example, now we have a circle with a radius 1, and we have this terminal point. So we have a terminal point P, xy, which is 1 unit from the center, from the origin. Here's the origin, here we label as O, and this is your x-axis here. Now, if you were to label this at 45 degrees, which more or less is 1/8 of the circle. So because a circle is 360 degrees, so this is 90 degrees here. So if the circle here it has a radius 1, then this point here is 1, 0. This point here would be 0, negative 1. This would be negative 1, 0. And up here at 90 degrees, I'll remove that. This point here would be 0, 1. Now, if this is 45 degrees, or 1/8 of the circle, now this is also 45 degrees here. So if you look at this triangle now, with 90 degrees here, this is an isosceles triangle, so these two sides are the same, so x is equal to y. And if you were to look at Pythagorean theorem, we know, remember, we have Pythagorean is a squared plus b squared equals c squared. We'll use this background here to find the measurement of the other two sides, or the values of the other two sides. Okay. So in this case here, let's go back to, so we're gonna derive the value of this point here. And I put it here as 1 over root 2, or 1 over root 2, but how did I arrive at 1 over root 2? Now, here we have a radius of 1. So we have a general equation. So we have x squared plus y squared is equal to r squared. The r, in this case, is 1. The radius is 1. So we have a radius equals 1. So we can replace the radius here with 1. So we have x squared plus y squared is equal to 1 squared is 1. Okay. So now we have, using the Pythagorean theorem, we can find the values for x and y. So how do we go about doing that? Now, if we have an isosceles triangle, I mean these two sides are equal. So now x is equal to y because it's an isosceles triangle. The size is 45 degrees. So because I so ONP triangle is an isosceles triangle. So x is equal to y. So I can replace the y with x. So x squared plus x squared is equal to 1. Now I'm going to find the value for x here. That's what I want to find, and then I'll find the value for y. So if x squared plus x squared is equal to 1, now we have 2x squared is equal to 1 now. Okay, so we're using this fact. So we're using the Pythagorean theorem here because this is a right angle triangle. Now we're going to solve for x. So solve for x. So we have, so it becomes 2x squared is equal to 1 divided by 2 divided by 2. 2 goes into 2 once. So we left with x squared is equal to 1/2. Now we want to solve for x. We square root both sides. So we have x is plus or minus. But we'll use the positive part of that because we're going to have a negative direction or a vector. This is a vector. Is equal to 1 over root 2. So x is equal to 1 over root 2. That's what we have here. So x is 1 over root 2. Y is equal to x. If y is equal to x, and x is 1 over root 2, therefore y is also 1 over root 2. So here we have this triangle at 45 degrees is 1 over root 2, 1 over root 2, this point here. So in other words, y is 1 over root 2, x is 1 over root 2. So if I were to go to my triangle here, so now we establish in your, it's a beautiful illustration in your booklet here. So this is 45 degrees. So P here, what do we have as P? It's at 45 degrees. It's 1 over root 2, 1 over root 2. Now, the beautiful part of this is that whatever we have in quadrant 1, we can have the reference triangle for that, which is, this is 45 degrees over here. So this is 1 over root 2. Now, here's positive and positive. But if you go over here now, this is my x, and this is your y. The x values over here would be negative. Because we are on the negative value. If x is negative, this becomes negative 1 over root 2. By the way, I'll show you what these are cosine, what they mean. Now, we're not done yet, because we can go on to the next one. Okay, down here. This is 45 degrees here, and 5 degrees down here. So the same thing we have here, but here, this is x here is negative. So 1, negative 1 over root 2. But also the y is also negative. So 1 over root 2. Now on the quadrant 4, 45 degrees, the x is positive, so 1 over root 2, and the y is negative 1 over root 2. So I can discover any one of these reference angle or related angles. Right. So this triangle, so anytime we have a triangle, this side here is root 2, and this is root 2 here. So we can just sine, now sine 45 degrees, right? So if you have the sine, which is opposite, by the way, we can simplify this, becomes root 2 root 2 over 1. So that's continuing. So we can, once we know one quadrant, we can have the related angles. The same. So now we establish the point Pxy as 1 over root 2, 1 over root 2. Now, we can conclude from this here. We talk about a reference triangle. Right. If you were to divide, now here we have our reference triangle. And here we have, this is 45 degrees, 45 degrees. So this is 1, this is root 2, and this is root 2. Now, if I were to divide, if I want to make these sides 1, I can divide this by root 2, divide this by root 2, divide this by root 2. So root 2 over 2 is 1. So we can change this equation and make it look nicer. I mean, a triangle. And you'll see this as a reference triangle. It's not 45 degrees. This looks more like 45. Has to be a square. So now this becomes 1 over root 2, 1 and 1. So this is referred to as a reference triangle. This is something you want to memorize. It gives you. So from here, we can derive a fair amount of trig ratios. So now let's go back to our unit circle. If you go back to a unit circle, now I'll repeat it here. And I'll just go 45 degrees in here. So this point here is xy. So pxy. And this is theta. By the way, remember when we're doing these angles here will be positive angles, and going negative here. So we're not doing that right now, but now if this is your radius, this would be your y, and this is your x. Okay. Now, if you were to make the radius 1 as a unit circle, if this is 1, what are the trig ratios? We recall from grade 11, what are your trig ratios? Your trig ratio is sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. And tan theta is opposite over adjacent. Now, using this fact here, let's look at what we have here. Sine theta, so the sine theta will be y over r, or 1. So we have sine theta here is equal to, if we let the radius be 1, this r equals 1. So we have y over r. Okay. So if r is equal to 1, we have, this becomes sine theta is equal to y, or 1 sine theta. So sine theta now is equal to y. Oh, let's write this a little cluttered. So simplify this. So we have r sine theta is equal to y. Now, since r is equal to 1, so we can say sine theta is equal to y, or y is equal to sine theta. Cos would be the same thing here. We have cos theta is x over 1. So this gives me, or over r first, and which is r cos theta is equal to x. So we can conclude, since r is 1, so we have 1 cos theta is equal to x. So here we are simplifying. We can say x now is cos and y is sine. So that's why we can replace the terminal point we have with the coordinates here. We can say that cos is x and sine is y. So we replace this now, the point P here. So we can say it's cos theta, sine theta. Now the tangent we concluded, we don't need it right now, but this would be opposite over adjacent, be y over x. Now nothing you can do about that. So tan theta is y over x. So from this definition, we can have these three forms. So let's put it nicely here so we can. So here we can put this all together. So we can conclude that sine theta, this is referred to the primary trig ratios. Sine theta is equal to y, because r is 1. Or you can write it the other way around. Y is equal to, just rewrite it as y is equal to sine theta, and we have x is equal to cos theta. That's why the x and the y become cos and sine theta here. So this is my x here, and this is your y, and that's theta. The radius is 1. And tangent is y over x. And it's all stemmed from the trig ratios we have. Just remember what they are, just sine, cosine, and tangent. I'll just write it here in the corner just in case you forgot about it. So sine theta is opposite. Here we have our triangle. So this is my opposite, adjacent, and hypotenuse. Sine opposite over hypotenuse. So cosine theta is adjacent for hypotenuse, and tan theta is opposite over adjacent. So if this is x, this is y, this is r, so we can say that it be y over r, x over r, and y over x. So put it in language form when p xy is a point so there's a terminal point here. It's a point where the terminal arm of the angle theta so we intersect the unit circle. So where does point intersect the unit circle? Then we can conclude that cos of x is equal to x. So we have, for one, cos theta is equal to x. Number two, sine theta is equal to y. Number three, tan theta is y over x. So these are what we call the primary trig ratios. These are primary trig ratios. There is a question in your booklet that asks you to state the primary trig ratios. And those are your primary trig ratios. So primary trig ratios. This will come in handy for some questions. So primary trig ratios we're working at here. Now, we can also look at, so here we have the primary trig ratios. The three primary trig ratios. Now the reciprocal ratio, the reciprocal means 1 over ln. So here we have cos is equal to x. Now, the reciprocal of cos is called secant. So we can put here the reciprocal trig ratios would be secant. So 1 over cos, right, is secant. So cos is x, so 1 over x, right? So in other words, 1 over cos. So 1 over cos theta is referred to as secant. So secant, you can put that here, is 1 over x. And this refers to your unit circle. So for example, if you go back to our circle here, see 1 over x now. Now cos is x over 1 or x over r. But if you want secant now, it's the reverse. It's the inverse 1 over x. Cosecant now is the reciprocal of sine. So if you were to look at this one here, so here we have secant is 1 over cos theta. Since cos is equal to x, is 1 over x. By the way, a way to remember, don't get confused, because secant, just remember that C and S is the reverse, right? So wherever you see the secant, and sine is cosecant. So that will help you to remember which one is which. It's kind of confusing. Which one? Okay, what am I saying? Secant referring to the reciprocal of sine? No. If the letters, look at the letters here. Look for the different letters, and that's the matching way of looking at matching. That's the way of remembering it. So cos matches the secant, like C, letter C matches the letter S, and S matches with C here. Just remember, right? They're not the same. So if you don't get confused, say like cosecant is the reciprocal of cos, because the letters are the same. If the letters are the same, meaning that you're wrong. You're on the wrong path. That's a way to remember. Tangent a little bit easier because it's cotangent, which is the inverse. So reverse of this will give us cotangent. Refer to as cot. The reverse of this would be x over y. And remember, this is cosecant. C theta is 1 over y. So these are the ratios. You'll want to remember these because they will come into the questions we're going to do later. Now, having said all of that, we did write the 45-degree angle here, called a reference triangle. Oh, here it is. This one called a reference triangle, the 45 degrees. Now, there are a few other angles you'll need to memorize, and I'll tell you why. So, once you remember these reference, it's called a reference triangle. So you need these to. So the first one we've established. We established the first one already. We already have 45 degrees. Make sure I do this correctly here. Well, let's see this here. I need to get a square, but I don't think you have a good job in drawing this, maybe. No, that wouldn't work. So reconstruct this. Look at an eraser. Think of 45 degrees as a box, right? And the two sides are equal, therefore it's an isosceles triangle. There we go. Looks like slightly off a little bit. This should be 90 degrees. Use the imagination here. 45 degrees, 45 degrees. And we make this side here square root of 2. 1 and 1. If you make the opposite sides here, and the adjacent side 1, then this would be root 2. Doesn't look like a root 2 here. Another way of looking at this is that if you have, this is your adjacent, that's your opposite. So, or using Pythagorean theorem, right? 1 square plus, so remember, like, you have this going to be your A, and this is your B. So you have A squared plus B squared is equal to C squared. So if A is 1, say 1 squared plus 1 squared is equal to, we don't know what this is, and let's equals square root of 2. Okay. Oh, this should be, this should be 1 over root 2. Oops. Okay. Right. Okay. So let's look at this here. Sorry, so once we don't know what this is, so assume we don't know what it is, we call that C squared. So 1 squared plus 1 squared is going to be 2 is equal to C squared. Therefore, C is equal to the square root of 2. Plus or minus, because we're using, so that's why we can say this is going to be a root of 2. Okay, the other reference triangle we will look at is 6 degrees. This would be 90. This would be 30 degrees then. And for this one here, which we'll prove this right now, because of time I want to go into. So this is my angles here. The hypotenuse would be 2, 3, and 1. So in this case, if we look back at this here, sine of 45 degrees is 1 over root 2, cos is 1. So we can conclude this. We have sine 45 degrees is equal to 1 over root 2. Cos 45 degrees is 1 over root 2. And tan 45 degrees is 1. 1 over 1, which is 1. If you look at this one over here, so we have sine. Now we can have, so we have 3 trig ratios here from this reference triangle. For this one here, we can have 6, because sine 60 degrees is equal to, remember, sine is opposite over hypotenuse, which is root 3 over 2. Cos 60 degrees is 1 over 2. And tan 6 degrees is equal to root 3 over 1, which is root 3. By the way, you can use your calculator and make sure I'm in, my mode is in degrees. Let me get my degree mode here. And let's look at one that's might be easier to figure out, cos of 60 degrees. If I were to write cos of 60 degrees, that should get 0.5. So these are all programmed into your calculator. Tan of 60 degrees, which is 1.73. The root of 3, so I can prove that. The root of 3 is also 1.73. Sine 60 degrees So sine 60 degrees is equal to 0.866. But I'll show you there's a reverse there. We'll complete the unit circle in a minute. And if you were to prove this, then we have root 3, okay, divided by 2.866. We'll see this will be the reverse for 30 degrees angle. So these are your reference angles for 60 degrees. Now we can then find for 30 degrees. That's the beauty of this reference triangle, because you're going to end up with just with one triangle with 6 reference angles. Because you can't memorize every single possible angle, that's why we can use a calculator. But some exam questions, you're not required, you cannot use a calculator. So they'll refer to these different angles in a question. So that's one. Let's look at sine 30 degrees. Now sine 30 degrees is 1/2, opposite, so it's a half. Notice it's the opposite of 60 degrees. So sine 30 degrees is the same as cos 60 degrees. Then we have cos 30 degrees, and it should be the same as sine 60 degrees. So let's do that. Cos 30 degrees is root 3/2. And tan 60 degrees will be root 3. In this case, it will be 1/√3, which is the opposite for me. 1/√3. So there you have it, your 6 reference angle here. We have them all based on these 2 reference triangles. So from one triangle we have with 3, and the next one we end up with 6 triangles. As I mentioned in the question across here, when we did this one from the booklet here, so when we had the 45 degrees, I was basically using my reference triangle here. So basically, if we say, look at this part here now, cos 45 degrees, which is x, is 1/√2. So here we have it here. So if we were to refer to our reference triangle, it's 1/√2 is your cos, and sine. So this point here, if I look right along on the y-axis, this point here, opposite here, this is 1/√2. This point here is 1/√2. Quadrant 2, it's negative. Now, by the way, there is an easier way to remember this class. Something called a CAS rule. Now, I'll just zoom out a little bit here. To remember, it's called a CAS C A S T. Now, what does it mean? This means cosine. I mean, cosine is positive here. I mean, all trig ratios are positive. I mean, sine is only sine is positive here, and then tangent is positive in this quadrant. So quadrant 1, all of the trig ratios are positive. So that's why the x and the cosine is positive, the sine is positive. Over here now in quadrant 2, here for this one, the cosine is negative and the tangent is negative. So that's why this is negative. Oops, this should be negative here. In quadrant 3, only tangent is positive. So the cos is negative and the sine is negative. And the last one over here, we get here, cosine is positive, the x is positive, the y is negative. We will complete the remaining ones. Here we have one, we already have the 30 degrees. Oops. So I'll leave this for you to complete for an assignment. I'm going to here. So in your booklet, you'll want to refer to your trig ratios here, 30 degrees. So 30 degrees, remember this would be your cos, and this is your sine theta. Cos and sine theta. And remember your cast rule. So cosine is positive here, so therefore your x is positive, your y is negative. And you can read along the coordinated plane. So for 30 degrees, and this is for 60 degrees, you refer to the trig ratio of 60 degrees and complete this chart. So this, once I know one quadrant, I can find the other quadrant because they're related, they're reference. These are my reference, so I'm going to back here. So now, having done all of that, the question is, okay, where will this take me? So it'll take me to the first question. Okay, we need to do. So just a little bit of note here. So the coordinate points on a unit circle can be used to identify the exact trig ratios of an angle in quadrant 1 and the trig ratios of the angle in other quadrant the same reference angle. So that's why if I know the trig ratio in one quadrant, in this case here, if I know the trig ratio in quadrant 1, these are all the different reference angle, 45 degrees, I can then use it to find the trig ratios for the other ones. Okay, just remember your sign. Cos and sine is negative in quadrant. And just as a nice way to remember, the cast called C-A-S-T, going counterclockwise. It's a nice way to remember the signs in the quadrant. Okay, let's look at one question today, and tomorrow we'll complete the other two questions. So let's go on to question. So determining the 6 trig ratios for an angle. Okay, and here you give an angle of 510 degrees. What you want to do first here is to sketch. You want to sketch 510 degrees. So what we want to do for A, so I'm going to put this up a little bit here. So sketch 510 degrees in standard position, right? And the reason for doing that, by putting in standard position, then we will find the terminal arm, and then we'll look for the reference angle. By sketching 510 degrees, we'll have the terminal arm, and then from that we'll get our reference. So to find our reference, R-E-F-E-R-E-N-C-E, reference angle. So let's X and Y coordinates. This is my X, Y. Now 510 degrees. Now we're going, because it's positive, we're going counterclockwise. Remember, positive, you're going this way, and negative going down. So I'm going 360. Now, to find the reference triangle, so we have 510 minus 360. That will give me 150 degrees. So now this is 360, so I need 150. It's just 90 here, up here. So 150 will be approximately there. So that's 510 degrees. It's 510, or if I were to look back here, so this angle from here to here, that is 150. So my reference angle now, this is my reference angle here, is 30 degrees. So this is my terminal arm. Let's say I have my circle. If I were to construct a circle, this is my P, X, Y. So this is 30 degrees. So I'll make it look a bit clearer here. I'll do another sketch here. So this is my draw my circle here. So this is 30 degrees. And this point here, P, X, Y. Okay. So essentially I'm using my reference triangle. So notice in quadrant, if you look at our CAST rule, CAST, it means the Y will be positive, the X will be negative. Your cos will be negative, your sine will be positive. So let's go back to our trig ratios. Remember, we said that cos, let's look at back here, back to our trig ratios that we established earlier. These are our trig ratios, x equal to cos, etc. So now we're going to use the 30 degrees here. So we're going to find our x, and this is a y. So now if I were to go down here, this is my negative x, and this would be positive y. So now cos 30 degrees. I'll go back to our reference triangle here. Cos 30 degrees is √3/2. So let's look at that here. So because we're looking at this over triangle now, this is our triangle. Cos 30 degrees. This is our reference triangle. So my reference angle is equal to 30 degrees. So cos of 30 degrees, now, mind you, it will be negative, right? So we have, okay, maybe I'll just show you how I got that. So x is equal to the 150 degrees, cos 150 degrees, which is equal to negative cos 30 degrees. Now, if you look at the reference angle of cos 30 degrees is √3/2. So x is negative √3/2. You could have made the adjustment because our CAST rule tells us that cos is negative here, or y, or x here is negative. So x is equal to, now y is equal to sine 150 degrees, or y is equal to sine 30 degrees. If you go to our reference triangle, sine 30 degrees is a half. So y is equal to a half. So this coordinate point here is negative 3 over 2, root 3 over 2, negative, and a half. And it makes sense because your x here is negative and your y is positive. And using your cast rule, sine is positive and cos is negative. Just to create variation, we're not done yet. We want to find our secant now, right? Recall that secant is the inverse of cos, right? So 1 over cos. So let's go on to, so secant 30 degrees, right? Which is 1 over cos 30 degrees. Right? Since we know it's negative here, right? So it will be the reverse, right? So this gives me secant 30 degrees is 1 over negative root 3 over 2, which is negative 2 over root 3. Now, you could have gone directly and said secant is equal to the inverse of negative 3 over 2. Negative root 3, the inverse of negative root 3 over 2, which is negative 2 over root 3. Okay, secant. Now, sine, we have sine, or in this case, we're looking at cosecant 30 degrees is equal to 1 over a half, which will give us 2, right? So you see 30 degrees, you're looking at here, is equal to 2. And the final one we'll look at is your tangent now. So tan 30 degrees, and we'll go to our trig ratio here. So tan, oops, it should be 30 degrees here. So tan 30 degrees is 1 over root 2, or root 3, 1 over root 3. But because it's in the second quadrant, it will be negative. Okay, so we have here tan 30 degrees could be equal to 1 over root 3. So cotangent would be root 3 over 1, which is root 3. But because we are in the second quadrant here, tangent is negative, so we have to put a negative sign in front of it here. So be careful with your sign. That's why it's important to remember the cast rule. Remember the cast rule, if you have a unit circle, cosine is positive, all are positive here, sine is positive, and only tangent. But because we are looking at this quadrant here, so tan is negative, and cos is negative. So therefore, tan 30 degrees in quadrant 2 is negative 1 over root 3. And cotangent, 30 degrees here, is equal to negative root 3. So your task, okay, I would like you to try or attempt question 2, which is check your understanding question. Zoom in here. So I would like you to check your understanding question on page 471. Determine the exact values of the 6 trig ratios for negative 420 degrees. So what you want to do here is to find the reference angle. The reference angle would be negative 60 degrees because it becomes 360 minus 420, negative 60 degrees. And or do a sketch of 420 degrees. And you want to derive the 6 trig ratios. You use a similar method. You will need your reference triangles. So you'll need these 6 ratios here. So your tan is here, 45 degrees. And also sine 60 degrees. So we have sine 60 degrees root 3 over 2. Cos 60 degrees is a half. And tan is root 3 over 1. Okay. And sine 30 degrees is a half. So cos 30 degrees is root 3 over 2, and tan 30 degrees is 1 over root 3. So use these, and also you would like to complete the exact values and for your measurement of the angles, 60 degrees. Okay. So our goal today, we still haven't completed all of our goals for today. So for today, we just completed the first determining a 6 trig ratio for an angle. So what we did today. In the next lesson, we'll be looking at determining all trig ratios given the coordinates point of a terminal arm, and all trig ratios and angle measured of given one trig ratio.